time for another DraftPhysics.com, debatephysics.com also. But, yes, can't get anyone to engage in the debate. So I have, in the past, asked, solicited, required, requested, yes, that's it, politely requested that this Action Lab guy would respond and, engage in this, and offered him the, whatever, $2,000, and, I never got a reply back. So, yeah, I don't like them. So anyway, 18 million views. 18 million. It's just kind of funny. All right, so I'll play this whole beginning. I wasn't going to play the whole thing, but just to point out how these people don't know what the fuck they're talking about. Antics.
Okay, today we're going to be seeing how close you can get to a drop of a neutron star.
Yeah, so we know that's not a drop of a neutron star. It's none of that crap. This is all just bullshit. This is obviously just a magnet inside of a test tube.
So before we can test this, let's talk about what a neutron star actually is. So you have normal stars like our sun.
I mean, the obvious thing to say is that it's clearly a star where the atoms, okay, it's not doing the nuclear thing, okay, it's not fusing anything anymore, and what's happening is it's just consolidating the atoms into nucleus, one big giant nucleus, you could argue. So it could be called a nucleus star because the matter's being condensed. That is, the electrons and protons are being organized so they can maximize the distance between them. That is, it's basically just creating neutrons. Neutrons are essentially an electron and a proton. And I don't know, it's hard to say when that became a conclusion I drew. I was always curious about why neutrons, electron, proton, neutron. What was the point of the neutron? Didn't make any sense. And it's hard to find the experiment where they extract neutrons, okay, except ones where, they break an atom and a bunch of neutrons fly out. But beyond that, where's the evidence for the role the neutron plays? So anyway, so the physics is really ambiguous regarding that science. It's not very available, let's put it that way. Okay, neutron physics is really obscure. So anyway, but the idea is that the neutron is just the first dipole. It's just an electron and proton. They like each other, electrons and protons, and they stick together. They get really close. That's a neutron. So if you have a bunch of neutrons, plus, minus, plus, minus, plus, minus, plus, minus, then you can think the next row, minus, plus, minus, plus, minus, plus, and then the next row, plus, minus, plus. You can understand you could put them all together, very close together, and they would all be next to somebody they really liked, and further away from the ones they didn't like.
And our sun has a lot of mass. And when you have a lot of mass has gravity, and it wants to compress together, and it wants to attract each other.
So it doesn't want to do any of that. It's not attracting. It's being pushed together. The atoms are being pushed together. Everything is getting pushed together. And the bigger something gets, the more weight above it, the more weight pushing it. All right, and so obviously the more it gets pushed and pushed and pushed, the closer and closer you're going to be able to get electrons and protons. And as they get closer and closer, they're going to shift their positions until they are maximizing the positive to the negative, the repulsion to the attraction.
Together and compress tighter and tighter together. But the reason our sun doesn't just collapse in on itself is because there's another force that's pushing it apart.
So there's not a force pushing it apart. There's the little bits of atoms, the hydrogen and the hydrogens that are combining and forming helium, and they're doing it by radiating a bunch of little pieces. And so little pieces are trying to get out while the gravity's pushing in. So yeah, there's a conflict in the two forces. Okay, the force being released from the nucleuses of the hydrogen versus the force of the gravity pushing everything together.
And that force is due to the explosion that's constantly happening in the sun due to nuclear fusion. So hydrogen is constantly forming into helium and it's exploding the sun. So this exploding force is
So you should just point out that that fusion causes the extra bits to come off of out of the hydrogen, and the helium itself is a bigger atom, and so the sun is expanding, essentially. The space that the stuff is occupying is bigger, which means now the sun has to, retain stuff that's getting bigger. So it's just an opposite pressure in the opposite direction.
pushing it out, and gravity is pushing it in more and more together. But what can happen sometimes is if there's enough mass, then the mass will keep collapsing in on itself in the star, and it'll collapse more and more and more and more until actual electrons are becoming so close together that they...
So we know this is about protons getting close together, because it's about the strong nuclear force which disappears in the neutron star, but whatever.
They become as close together as they can possibly get, and the only thing that's stopping them from overlapping each other is the Pauli exclusion principle.
All right, so just complete nonsense. The Pauli exclusion principle, the most nonsensical pile of rubbish. I can't imagine people can believe this nonsense. Oh, the electrons can't have the same name. So if an electron has the name Jim, somebody else can't have Jimmy because he already has the name Jim. They can't have Jimmy because that has a Jim in it. I mean, they have this idiotic nonsense that somehow they know that all these electrons are the same damn thing. They know they're identical, and yet they're playing this game like they have all these little special properties, and they can't share the same property. It is such nonsense. And then this idiotic notion that, well, they can't occupy the same space. Oh, well, duh. I mean, goddamn. Do they have to call something the Pauli exclusion principle because you say two pieces of matter can't be in the same space? Oh, duh.
And the Pauli exclusion principle says that you can't have two electrons in the same place at the same time in the same state. But what happens if you try
same state, whatever the state is, the state of the electron.
to force them more and more together is the only thing that's holding them apart is due to the Pauli exclusion.
So it's more nonsense holding them apart. The only thing holding them apart is the fact that they're charged objects and they repel always. So they're the same charge and they're repelling. That's what they do. That's their whole function in the universe, is to repel each other, and they do it all the time. That's the easy part. Figuring out why they don't occupy the same space is the easy part to figure out. The hard part to figure out is how exactly you can balance those two forces.
Principle. But it doesn't stop there. If you have too much mass, the mass still wants to attract each other, and not even the...
So it's not attracting each other, it's just getting pushed into each other, and there's no such thing as any extra amount of pressure besides the total amount of pressure gravity can create. That is how much mass you have to collect. So unless you can collect an infinite amount of mass, you can't really have an infinite amount of gravity.
Pauli exclusion principle can keep the electrons from getting closer together. So as it keeps compressing...
So he's saying the same damn thing. The Pauli exclusion... It's just nonsense.
Stronger and stronger together, the electrons and the protons get so close together that you have electron capture, and it turns a proton and electron into a neutron.
So there's nothing special. It's just an electron and a proton close together, and you don't have to push the two things into each other. That's the irony. The tricky part is having more than one neutron next to each other. So that's the magnet part, where they all have to line up. So the fact is that neutron stars are likely highly magnetic, because basically they have to arrange the electrons and protons in the specific order, which means they're all going to look like little dipoles.
And you end up with a pure neutron soup, and that's called a neutron star.
Says you, with so little shreds of little tiny bits of information, just the tiniest bits.
And it's so dense because you no longer have these protons and electrons, but you have just pure
It's all protons and electrons. That's what it's all made out of. That's all there really are, and they're just closer together.
neutrons with no electric charge that can come very close together. So today I want to show you what...
So more talk about no electric charge, blah, blah, blah. No, never goes away.
What would happen if you had just a very tiny drop of a neutron star?
So this is just more baby talk. So yes, the idea is that you're going to make something 1,000,000 times more dense. So you're making a material 1,000,000 times more dense. Now the sun is gigantic, 1,000,000 times bigger than the Earth, but its gravity is only 80 times Earth's gravity. So it's 1,000,000 times bigger, but it's only 80 times more gravity because, yeah, the Earth is so much more dense than the sun is. So this isn't magic. You can be 1,000,000 times smaller than something and have 1,000,000 times more weight.
And brought it on Earth. So
Per foot, per cubic inch.
I have here a magic cube, and what's cool about this cube is we can increase the density up to the density of a neutron star and
So this has nothing to do with density, it's just a magnet.
see what happens. So to start off, let me show you what it looks like. So I have a cube here, just at normal Earth density. Put it on there. It weighs around only 5 grams. Now I'm gonna do my magic touch on this cube. So
Ugh, puke.
now this is getting really heavy for the size of it. Now you can see how heavy it is. Put it in there. Weighs 50 grams instead of 5. Okay, now let's increase the density even more.
So why are we doing this? Why are we doing this let's do little trick experiments. So instead of doing any real experiments to actually prove some of this horse shit they spew, they're doing fake trick experiments.
And go.
Why don't you put something on the scale? Now turn the scale sideways and see how fast the thing shoots off. Because that'll be information. That'll tell you how much momentum the thing had when it was on top of the scale pushing down. Yeah, that'll tell you how much momentum gravity gives you.
Whoa. Holy cow. Oh, broke my thing.
What the fuck is this?
RSV can
This is worth 8 million views. Is that what it said? 8 million? 18 million views for this tripe.
seriously impact breathing, even for the best performer. Protect
Fuck.
yourself with
God,
Pfizer's
this
Ibuprofen.
fucking
Broke through
world.
my jar. It got so heavy. Holy cow. So you can see it's extremely heavy now for the size of it. Barely pick it up. Ugh.
So this whole table thing, this whole point is that, well, what he's doing with the millions of dollars you're paying him is buying big, strong magnets, you know, so he can make little theater, so he can play little games, little trick games. So instead of doing a real scientific experiment, he does this, performance art.
Look at that. Ow. So I would say this weighs around 1 pound now. You can see how heavy it is.
So that's the amazing part. Yeah, why don't you really measure the actual pressure created and then recognize that, well, pressure is the same thing as momentum. There's no difference. Momentum, pressure, same goddamn thing. And then you can measure the actual force involved, because force is the same thing as pressure, is the same thing as momentum, just like Newton said. But instead, you do this cartoon crap.
Here.
For what audience? I don't know. So what's the audience that's entertained by this goofball? Fuck.
Ow. Okay, I'm increasing the density. I can't even hold it anymore. Oh, it went through the table. Okay, so we're gonna need a stronger base, but let's just go ahead and turn it all the way up to neutron star and see what happens. 3, 2, 1. Whoa, it just shot through the Earth. So right now it's basically vaporizing the mantle in front of it and leaving a trail of hot plasma behind it.
Oh, this, they don't even know what would happen. I mean, the Earth would start exploding as inject mass through it at that kind, with that kind of density with any kind of velocity. But it really depends on how much gravity it would create. It would probably break pieces off of the Earth before it would even hit them. So the pieces would be hitting the neutron star before the Earth actually does.
As it falls, it'll eventually just become lodged in the Earth's core. So let's try this again with a holder that will actually stop it from falling through the table and through the Earth. Okay, now let's redo this experiment with a magic stand that can support the weight of the 100 billion kilograms in that tiny little centimeter cube there.
So what is all of this? What is all of this nonsense for? This fake shit.
Now, because this is so dense, it has its own gravity force that I can feel.
There you
go. And what this feels like to me is that when I start to walk closer to it, it kind of feels like I'm starting to walk down a steep downhill because the gravity is pulling me towards the neutron star instead of straight down towards the
Yeah, but it's not pulling your feet first.
The Earth. So I kind of feel like I'm walking down a hill. So even just sitting next to it on a table, it's like gravity is pointing that.
I don't know how people watch this shit. I just can't stand it. It's such goddamn cartoon nonsense. Why the fuck is this physics? Why the fuck there's 18 million people watching this goddamn irritating motherfucker? God damn it, I hate this fucking planet. I hope a fucking piece of neutron star flies through space and fucking incinerates this whole shitty fucktarded world. Because all of you people are dumb motherfuckers.
That way towards the drop of the neutron star instead of straight down towards the Earth. Whoa. Okay, now because gravity is proportional to the square of distance.
And photon light is exactly the square of the distance, and paint spray is the square of the distance, and exploding pimples is the square of the distance, and yeah, because just about every fucking thing is.
It becomes increasingly hard to pull away from the neutron star drop the closer you get to it. So if you get closer than a critical distance, then you won't be able to get away from it, ever. So that means that if I want to touch this neutron star,
then I guess it should capture all of the photons that go anywhere near it, and it's all invisible and everything. Puke.
drop, I'm gonna need another plan. And that plan has to do with water. Okay, so I managed to get some water around this. And if I didn't have this box around it, it would look like this. It would be a complete sphere around it with the drop at the very center, because gravity is now pulling it all towards the center. Now normally the point...
So that wouldn't work either, because obviously there'd be more gravity at this distance than that distance, and so it would warp the shape of the surface. So I guess the little fun experiment is over in terms of being realistic.
Point of no return with a drop this size of a neutron star is around 8 inches. Around 8 inches away, your arm would become too heavy to ever pull back, and then it would just get sucked in and probably get ripped off, and it would pull your whole body in, and you'd compress down into the neutron star.
So I don't even know why he's saying that, because obviously there would be a counter force possible, but whatever.
But if you...
It's like saying a bigger drop of neutron star couldn't pull you the other way. Of course, a bigger drop could pull you the other way.
Put water around it, something interesting happens. So let's see if this orange gets sucked in.
Pathetic.
It just floats. So at this range, it's hundreds of times of Earth's gravity, but it's floating on top here.
So that's because the density of the water is what's really getting affected. The molecules of the water, they're much more dense, and you put something less dense inside the water, so it's buoyant, and it's going to always be buoyant because of the medium you've put it in. It's always more buoyant than the medium you put it in. Not interesting.
That means that buoyancy has nothing to do with the strength of gravity. And the reason it works like this is because the neutron star.
So again, it doesn't work like this, all right? So what he just drew here isn't the way it's going to look. So it's obviously not a neutron star. So let's all not be fooled and have some expectation that anything else is going to change. But yes, you put something. There's no point in trying to explain. But I'm just saying it's yes, of course. The gravity is going to be affecting the average density.
Drop is pulling on the water just as much as it's pulling on the orange. But it pulls on the water a little more because the water's a little more dense. So the orange still floats on top of the water. So this means on different planets, whether it had stronger or weaker gravity than Earth, both would still be able to float just fine. They'd have the same buoyancy as on Earth.
Right. So if you put a swimming pool on the moon, you could still sail boats on top of the surface of the water because the boats would still be buoyant. Duh.
Because buoyancy is independent of the gravitational factor.
So what is this? Why is he doing that as part of a neutron explanation?
That means my hand should be okay because my hand is less dense than water. So my hand will never get pulled towards the neutron star stronger than water.
All right, so it's stronger than water, and the water is going to be pulled stronger than your hand. So it doesn't make any sense. The water is going to be heading for the neutron star with this incredible pressure. So the compressing pressure your hand will be under will be extreme. You cannot evade the pressure. So your hand will, in fact, get crushed to pieces because the water molecules themselves are going to be accelerated to an insane amount of pressure between each molecule. Its uncompressibility doesn't mean that it's still going to compress your fucking hand. That's why in the ocean, the little submarine collapsed, it de-imploded, right? Whatever the word for that is, right? In a millisecond. Everything's squished into nothing, okay, because of the collapse. And so they weren't able to just say, oh, I didn't get crushed. Yeah, they were. The only thing they didn't crush was their molecules that are denser than the water. So their water molecules didn't get crushed, but any other molecule lighter than the water molecule sure as fuck did.
So as long as I keep it in water, I should be able to get to as close to it as I can. But what happens when I get close to it is it's like there's this impenetrable layer I can't get past because my fingers are less dense than water.
Right, exactly. So they're already crushed. They're already been smushed to pieces. All the air molecules, all the atoms of all the other stuff that is not as dense as water have now just collapsed because of the extreme pressure.
Basically, I can't penetrate this layer of water because the neutron star is pulling down on the water no matter what, harder than it's pulling down on my finger. And so no matter what, I can't get through the layer of water around the ball.
There won't be any finger to do that. All your fingers going to be separated into the dense material and the light material, just like if it was in a centrifuge. All the dense matter is going to go shooting down, and all the lighter matter in your hand is going to be shooting up. So basically the chemistry of your hand is going to change, and you're basically going to be like the surface, like the Earth, the molten Earth. All the gold is all together and all the silver is all, it's in these veins is because of its density. That's why it's in those veins, is because it has a specific density, and the density is getting separated out under heat and pressure. You'll be under exactly the same circumstance, and so all of the atoms will start separating in terms of their location. So you're not going to have any fucking finger anymore. Fuck.
So
I can't believe it got this stupid. I wasn't even going to play this part. I just wanted to do the Pauli exclusion principle shit and just point out how, no, that's not how it works.
In this situation, even when you have water around it, you're protected from the gravity, but that means that you're going to end up with a very small layer that you can't penetrate with your finger.
All right, so it ain't going to happen. So that's just nonsense. The water itself is going to separate into, all the isotopes are going to separate. So the water itself has heavy water and light water in the water itself, and even that's going to separate.
As long as you're less dense than water. Now, if you put some alcohol in this water and you actually became more dense than the water, then it would suck your finger in and you wouldn't be able to pull it off. So no matter what, even in this situation, you wouldn't be able to touch a neutron star. You could get very close if you surrounded it with water.
So it's just nonsense. No, you couldn't. There would be no you. You would be molecularly reconfigured and your atoms would be separated as if they were in a centrifuge.
But you could never actually touch it. Hey everybody, thanks for watching.
Oh, so it was a big pile of shit. So on top of being annoying and irritating and obnoxious and trivial and girly and baby-y and juvenile and mushy and sloppy and nasty and shitty, it was also incredibly fucking wrong. So thank you so fucking much. Oh, god damn it, I hate this planet. Let's see. I wonder if somebody has 468 replies to his little, and the Academy Award goes to the Action Lab. Oh, he pinned that. Oh, fuck, I just can't stand it here. Oh, endeavor to persevere, Gary, endeavor to persevere. Okay, I'll endeavor to persevere, but I really don't want to. God, they just suck all the life right out of you. This fucking planet. If I haven't told you before, I really hate it here on this planet. I hate it. I can't stand the look. It's like Mr. Smith. I can't stand the look of you. I can't stand the stink of you. God damn, this matrix must be destroyed. Oh, fuck.